Hi, hello, I'm Kiran Kumar from Nature of Physics and Art. Today topic is Ohm's Law. This is the part 3 video from the current electricity. What is Ohm's Law? That is the potential difference across the any part of the wire is directly proportional to the current. So this is the battery. Potential difference is changing, increasing the potential. So initially I am taking here 2 volts potential and corresponding current is I in the ammeter reading. See, this is the closed loop and R is the resistance. We are finding potential difference across the resistance with the help of voltmeter, and ammeter is always in series combination in the closed loop and voltmeter always parallel to the resistor. Okay, so now here potential is increasing, then we can identify in the reading of ammeter current also increases. Now I am taking 4 volts potential and current is 2I. Just assuming whenever potential increases, then current also increases. The potential difference across the any part of the wire is directly proportional to the current. So potential difference is directly proportional to the current. So potential difference, which is equal to R into I. R is the proportionality constant, that is resistance of the wire. So R is the resistance C. Now we can write V, which is equal to IR. According to the Ohm's law, V is equal to IR. Potential difference is directly proportional to the current. And modifying this equation, we can write current is equal to V divided by R and the resistance is equal to V divided by I. See, now here we are doing the experiment with different resistance, and before going to this, here we can identify one graph, that is VI graph. So on the x-axis is voltage and on the y-axis is current. So voltage is directly proportional to the current, that's why straight line passing through the origin. So here slope of the graph, that is tan theta, which is equal to I divided by V. Opposite is current and adjacent side is voltage. So now here we are doing the experiment with the different resistors R1 and R2. Here resistance is increasing from R1 to R2, that is R2 is greater than to R1. For example, now the resistance is R1 and the corresponding voltage is V1 and corresponding current is I1, like this. Okay, so the same graph here I am taking. Here current increases with increasing the voltage linearly. So this is the R1 resistance at a temperature T1, then corresponding current is I1 and corresponding voltage is V1. Now R1 resistance is replaced by the second resistor R2. Resistance is high, then the corresponding voltage is here V2 and corresponding current is I2. So then the second graph is, this is also passing through the origin straight line. Here R2 is the resistance at a corresponding temperature T2 and that slope is theta 2 and first one slope is theta 1. Here this current is I2 and corresponding voltage is V2. One thing clearly we can understand from the graph, current is decreases from I1 to I2. So current decrease, okay, from I1 to I2. That nothing but that is resistance is increases from the R1 to R2. So resistance increases from R1 to R2. 2. So one thing we can understand here, I1 is greater than to the I2 and R2 is greater than to R1. See, from the graph we can write the slope also. So the slope of the graph, so tan theta 1 for the first resistance, which is equal to I1 by V1, and second tan theta 2, which is equal to I2 by V2. Okay, from the graph we can understand, from the slope also, here theta 1 is greater than to theta 2 and current I1 is greater than to I2. Okay, and potential is V2 is greater than to V1. See, clearly I gave that relation in the graph and also related derivation. Okay, so whenever resistance is increasing, then corresponding current is decreases according to the Ohm's law. And here again I am writing clearly, so that, so first one, I1 greater than to I2. Next, here theta 1 greater than to theta 2, V2 greater than to V1. Next, R2 greater than to R1, and temperature, okay, T2 is greater than to T1. So this is the information about the Ohm's law. Thank you very much. Just a second. Just a second. Here current decreases from I1 to I2 and the resistance increases. Nothing but whenever resistance increases, here current decreasing. The reason is electrical energy converting to heat energy across the resistance. Thank you. Please like and subscribe my channel and share to your friends.